Hey, what's up, people? We're going to do a teardown of this wonderful piece of equipment that I've got sitting on the bench, appropriately named Benchtop Pro. Now, that doesn't give us too much of an explanation as to what it is. So I decided to do a Google image search to see if I could, maybe come up with a more accurate name for it or an actual name as to what it's called. And there's a bunch of things that come up. And there's some that say it's a 7-in-1 TV lantern. There's others that say 8-in-1. As best as I can tell, this one only has 7 functions. So if we take a look around at this thing, we see that we've got a flashlight. There is a compass on the side. There's a thermometer on the opposite side. There is a button that says siren. There is a lovely 5-inch CRT, but it's black and white only. It also has a radio function. And if we turn it around to the back, we have a fluorescent lamp. I think I may have overpaid a bit for this at the local Goodwill. It was $30, and it has a few issues. I've already tried powering it up. And speaking of power, if we take a look at the bottom, we see that we've got a cavity down here for no less than 9 C-size batteries. Unfortunately, it was missing the bottom battery cover, so that's not in place, as you can tell. So let's power it up before we take it apart, see what all it can do. And it's not going to be a repair video or anything like that, but maybe in the process we can figure out why the TV has an issue. As we'll see right now when we power it up, it seems to have a vertical deflection issue. And this lantern or the fluorescent lamp in the back doesn't appear to light up. So let's get some power to it. It plugs into this barrel connector in the back. And we see we also got some potentiometers for adjusting the settings on the TV. And I've already got a barrel connector hooked up to my bench power supply. So if we plug this into the rear, there's also a switch right next to the barrel jack that says power, external, battery, or charge. I'm assuming that if you've got rechargeable batteries and you apply a power input, you can charge them that way. And so there is a switch down at the bottom of the front side that says lantern, and then lamp, TV, and radio. So when it's on lantern and we hit the power button, shield your eyes, I don't want to blind you, it did nothing. Oh, I think the lantern refers to the fluorescent lamp in the back, and yeah, that one didn't work. As you can see, it's not lighting up at all. So I guess there's either something wrong with the lamp itself or the inverter for it. So okay, so I think lamp is the flashlight. Yeah, there we go. So you've basically can only do one thing at a time, depending on where you've got the switch set to. So if we go to TV and we power it up, well, we got some noise coming out of the speaker. Let's just turn that down. And we'll see that it comes up, but we just get this line going all the way across, and there's like no way to adjust it. Like you can see, I think that one's brightness. I don't remember what the knobs were off the back, but yeah, we see, I think this is the horizontal hold. We see it gets a little jumpy there. So I cannot get it to go all the way up. If we tap around, doesn't say, oh, thermometer just popped off. It looks like it was supposed to be glued inside of that little slot for it, but apparently it came off, so that's quality. I think that's glass, so I'll just set that aside. Anyways, yeah, TV does not work. The lamp in the back doesn't work. The radio does work. You've got to set this other switch to the AM or the FM side, depending on what you want to listen to. So right now it's on AM. So if I turn that up, maybe you'll be able to hear it. And then we use this to tune it. Oh, also there's an antenna on the top of it. So you can extend that. And see, you can. So the radio does work on both AM and FM. Oh yeah, I almost forgot the siren button. Let's see what that sounds like. Cover your ears. I bet the siren probably uses a small transistorized oscillator of some sort. So we'll see if we can figure out what exactly drives that. I doubt that it's going to be like some sort of dedicated circuit that produces that particular sound. The siren volume is not adjustable with the volume knob. It's got like one setting only, and so that's about as loud as it gets. Oh, and the flashlight or the incandescent bulb is replaceable by twisting this thing counterclockwise, and then it just has a bulb that's screwed in, that little thing. I don't see a voltage stamped anywhere on the can, but I'm going to assume that it's probably a 12-volt lamp. Oh, never mind. It says 9-volt, 300 milliamp right below the actual base of the bulb. And it looks like this thing will be fairly easy to open up. There's a total of 4 screws that are easily accessible. I don't think there were any. No, there's none down in this area. Oh, and there's also an external antenna connection right next to the power connectors we can see. And there are some screws up on this top portion, but it doesn't look like those will stop us from opening this up. Okay, unfortunately, I seem to do this a lot, but I didn't catch that my microphone wasn't recording for a couple minutes after I removed the screws. So I'm redoing this part, and I'm going to be acting like I'm all surprised again about what's inside. So here we go. I've removed the 4 screws, and now the front part is loose. So let's see what we've got inside. And would you look at that? There's electronics in this establishment. All right. So we've got a few wires that are connecting all these boards and the stuff from the front side to the back cover. And there's a cute little CRT inside, as you can see. So I'm going to be careful with this because, as we can see, this large-looking red wire, that's a high-voltage line going to the CRT, so I'm not going to be touching anything on these boards just yet. Be warned that, this stuff does contain high voltages. But we've got another set of 2 wires that are going to this top board. That appears to be the inverter for the fluorescent lamp in the back. So there's a 2-pin connector, and that just comes off. There is another single wire going to a single connector on this bottom board. And that connector is for the antenna up at the top. So we disconnect that. There's another 2-pin connector. This is for the batteries at the bottom of the case. And then there's another 2 wires that are going to a speaker on the side of the case, and the connector for that is like all the way down at the bottom, and actually have not gotten that far yet. So the speaker's just kind of glued in place, and I already broke the glue, so I can just slide the rest of the speaker out, and that frees the rear. And as we can see, I've already also removed the screw from this cover. We can remove that cover that exposes the lamp. Now we can just twist this out of the way. So this lamp is basically being operated as kind of like a cold cathode fluorescent lamp. If we take a look underneath this reflector, there was actually 2 screws on each end that were holding it in place. So now this is free to just lift out. We can see that that blue and the white wire that were coming from this top board, one goes to this top terminal, the other one goes to this bottom terminal. So basically this little inverter board is just generating a high voltage, and the lamp conducts that way, and that's how it lights up. So not much else to see in this back section, and I'm not going to bother removing any of these screws. This is all just plastic handle stuff, and the screws hold it all together. So that's about it for that part. We'll just put that aside somewhere. So I would say if we had like more than, one terminal going to each side of this lamp, that we could check the filament and see if, that was bad. But the way that this works, the filament doesn't really do a whole lot in terms of like glowing to get it started. So I have a feeling, if anything, there's probably going to be something wrong with the inverter board. So let's move on to this portion of the teardown. And as we can see, we've got several boards. This bottom one is going to be the main TV board. You can see we've got the tiny little flyback. There's another looking transformer looking device. Let's zoom into some of this stuff so we can get a better look at it. So that is going to be the TV tuner. And we have a tiny little neck board on the back of the tube. Looks like it's got 1, 2, 3, 4, 5, 6, 7 pins going into it. It looks like it doesn't use all of them. No. So that's going to be for the heater in the tube and possibly some of the focus and some of the other electrodes inside. These other wires, those are for the deflection coils. And if we look down at this capacitor, that capacitor is bulgy. And it appears that it's probably in a section that may have something to do with the deflection coils. That could be a reason why the vertical deflection on this isn't working properly. So I guess I'll see if I have a comparable replacement capacitor. We can replace it, see if that fixes the vertical deflection. So there is a small or a TO220 device. Looks like that might be part of an oscillator. That could also be the horizontal output for a transistor. It does look like it. Some of the traces go from that into this section with the flyback. So could be that that's what that's for. These are the 3 pots that are accessible from the back. And I should probably look and see what those were supposed to be. Okay, there we go. So the rightmost one, that's contrast. The middle one is brightness. And the leftmost is vertical hold. I don't remember if I said horizontal hold when I was first talking about it. But anyways, it's vertical hold. And then on the tuner side of the unit, we also have another board. This is going to be the radio. And it's pretty obvious. And there's not a whole ton of stuff. It looks like it's got this chip that's probably going to be like the main radio chip. That's got a number of CD 2003 GP. I'll see if I can find any information on that. There's going to be the tuner capacitor. This is going to be the AM antenna. And we've got another 3 wires that are going to a small board in the front. That's going to be the 2 switches. This one's the siren switch, and this one's the power switch for the entire unit. And there's that top board we were talking about. So there's 3 wires going to that. I'm guessing that one's going to be a ground, one's going to be a positive for the flashlight in the front, the incandescent bulb, and then the other one's probably going to be for lighting up or turning on the inverter for the rear lamp. So let's remove this connector. And there's another connector that goes to that socket for the lamp. So it looks like you should just be able to pull this right off. And that glue came right off. So there we go. That's the inverter board. Very, very basic. It's just got the small transformer. And then that's going to be the transistor that oscillates it to generate a high voltage. We can see that it's supposed to have a heatsink. Looks like they were like, nah, just send it. So we'll see if this works. I don't see anything bad about it right off the bat. Those resistors look like they're fine, like they're not burnt. These are just like Mylar film caps, a couple electrolytics. So looks like, yeah, power was going to come into this connector. And then we just got to figure out what goes to what. Looks like maybe there would have been a switch there in some other models or something. We can see we've got something that would have been in that spot. It would have had a total of 3 contacts. But as it is, it's got this one jumped over to that side. That goes off. No, that was going to the front lamp. So, okay, so that's not going to be for the fluorescent lamp. It's going to be for the incandescent bulb. So that middle one then is going to be the one that, yeah, that looks like operates the fluorescent inverter. So we'll mess with that a little bit. I'm assuming that we can just apply like 12 volts to it and maybe see if it works. So let's just set that aside for now. Let's go ahead and discharge the tube just in case. I don't want to get a bad zap or anything. So this is going to be fairly simple. Just got an alligator clip connected to the metal end of the screwdriver. I'm going to hook up this side to the ground. That's available right at that screw terminal. And I'm just going to push this underneath the cap. And I didn't really hear much. I kind of really doubt that this tiny tube is going to hold that much of a charge. But now I can remove that anode cap. There we go. And then the neck board. This is glued in place. So there you go. Just remove a chunk of glue. I can pull this off. There we go. It looks kind of crusty. It looks like just some leftover conformal coating or something. And so I think that will allow us to pull this assembly off of the front. Yeah, most of it comes off. But unfortunately, looks like okay, that's the ground wire. If I remove that screw, that should loosen or at least release that portion. All right, so that frees the ground. We've got the other 3-pin connector going to the switches. And then we've got the 4 that go to the deflection coils, but unfortunately, those do not have a connector. It looks like it would have had a connector on there, but they decided to just solder it straight into the board. So I can desolder them from there, or I can desolder them from there. I just keep track of which one goes to what position. So I'll just desolder them from that side. All right, so that frees this from the front, the tube and all that. The speaker we still cannot release because there is no connector on the board at the bottom. It's soldered directly onto the board, so it's going to have to fly with the rest of the stuff. So this entire assembly is almost like a small chassis of sort that'll fit into the rest of the casing. We've got a couple screws that are screwed into these 2 brackets that hold the bottom board on. And on the side board with the radio circuitry, that's also screwed into this middle board. You can see we got 2 screws. And so not only does this knob operate the variable capacitors for the radio, it also activates or controls this potentiometer. So that's a potentiometer that's going to be adjusting voltage, I'm assuming, to the tuner so that you can tune into different TV stations. Not that you'd be able to tune in too much anyways. Nowadays, there's like barely any analog stations. I was actually surprised to be able to pick up a station nearby with another little old portable TV that I have. I'm guessing there must be one around here, obviously, if I can still tune into that. But as far as everything else goes inside of this device, there is what's probably going to be the main TV chip right there. That's a CD5151 CP. And there's also another small semiconductor device. It looks like it says N45H. I'll have to look up those numbers. There's actually a fuse right there. That looks like that's for the input. We've got a big resistor. I bet you that's going to be for the charging portion of this switch in the rear. So let's see if we could tell where it goes. Looks like right in the middle of this device. I can't tell what that is. Okay, that says L7815. So that looks like a 15 volt regulator. I'm guessing if the voltage coming in is too high, that's what that's for. Okay, so it looks like when you have the switch on charge, it uses that regulator, and then the output goes through that resistor. Yeah, there's a diode. It jumps over, and that's how you're able to charge the batteries. So I guess they're expecting if you don't have a regulated input, then that's going to limit it to about a 15 volt charge voltage. And then the resistor is used as basically like a current limiting resistor. That's why it's so big and chunky, because it's going to generate some heat. There's that antenna connector, the one that goes to that single wire going to the top. There is a ribbon connecting this top board or the middle board to the bottom board, as well as another set of 4 wires. That's all going to the radio section. There's another 2 sets of wires going there. So that looks like antenna stuff. That's probably why it has. Yeah, looks like it. Yeah, so yeah, that all looks like antenna stuff. We've got another TO220 device connected with the connector there. Just plugged it straight into that. I'm going to guess that maybe that's being used as a voltage regulator. Yeah, not completely sure about that, but I'm going to guess for the time being that maybe that's what that's for. There is another IC down at the bottom. I mean, I'm not going to be able to see the numbers on that unless I remove this board. That's probably, I'm guessing, going to be audio amplifiers, since the volume knob is down at the bottom as well. And then the speaker has its 2 wires going right there. So let's see. Looks like we've got something going off in this direction. So yeah, it looks like it goes into that. I'm going to guess that that's going to be a capacitor. Yep, that's a capacitor. So yeah, that looks like it's going to be the audio amplifier, and it's just going to be like a little mono thing because this is not going to be stereo or anything. Down there, we have a few transistors and some capacitors. And judging by these, I'm going to guess that that's the oscillator section for the siren tone. And if we apply some power, we could probably see it with the scope, like what exactly is going on in that section. I'm going to guess it's kind of like a multi-vibrator arrangement of sorts, and that's how that works. And maybe one of the transistors is being used as an amplifier. Okay, I removed the 3 screws holding this board to these brackets, and looks like one of them is being used as a ground that links the top portion to this bottom portion. But this top one was already loose. I have not touched these. That's just how it was. And the bottom one also felt a little loose, so don't know how good of contact they were actually making if they're loose like that. So let's see if we can see the number on that one I see. Oh, dumb. The number's on the front. Okay, so it looks like the number on that says CD 7313GS. So looks like maybe there's a bunch of these ICs that they're all kind of similarly numbered. So they're probably all from the same company, specifically made to be used for stuff like this. That's going to be my guess. Okay, I looked up data sheets for some of the numbers on these chips. The only one that I could not immediately find anything for was that N45H. Although on the board, it's got a label of SF201. So I'm wondering if that means SAW filter. And it looks like there's 2 different pin combinations for that component. It looks like it can be a round one with a total of 5 pins, or this inline one, which also looks like it's got 1, 2, 3, 4, 5. 5. Yeah, 5 pins. So looks like there was an option there for that. And so, I mean, sure enough, a lot of this stuff is exactly what I thought it was going to be. The only issue is that 2 of these data sheets were in Chinese. So, yeah, everything. But it's got the pin on everything. I'm sure we could use like Google Translate or whatever to translate everything. But, I mean, I'm not going to bother to do that right now. The 7313GS, yeah, that's a audio amplifier. Looks like it's capable of 500 milliwatts. So it says a VCC of 6 volts, and I guess that's at those particular values. And it looks like it's got a voltage range of 4 to 14 volts, and that there's a pin out, if you can read what it says. So the third IC was the radio. That's the only one that I found in English. And of course, it says FM AM radio IC. And I mean, it's meant to have like everything pretty much like integrated in. So it does not need a whole ton of external stuff. You even get a diagram, like a test circuit there. So you can see that it really does not require a lot. There's actually let's see, this test circuit. I thought I saw an actual application circuit. There it is. So that looks like that would be that 4-gang adjustable capacitor or variable capacitor. And then you've got your antenna stuff. Looks like some capacitor stuff, or possibly like filtering. And yeah, it's extremely simple. This looks like it might actually be the audio output. Let's see, pin 9, pin 11. Let's see, 9 says ground out, 11 out, detector output. So yeah, it looks like that's what that is. So if you select the FM, then that's the output, goes out to that. If you have AM, then it can go out to that. So yeah, I think that's about it for those. Well, that's pretty much all there is to actually see inside this thing. So let's see if we can make the lamp light up and see if we, or maybe figure out why that's not working. And then after that, I will replace this capacitor. It turns out it's a 10 volt, 2200 microfarad capacitor. I'm pretty sure I have some of those. I think I saw some the other day when I was going through my stuff. I'm pretty sure I got some new ones, but if not, I might at least have like a used one. So we'll see if that gets the vertical deflection going. But first, let's do this one. What I don't know is if it uses 12 or 9 volts. Looks like some of the stuff inside uses 9 volts. So let's plug in this connector there. And I'm going to leave this on the lantern setting. I'm just going to be careful not to turn it on to the TV setting, because that's going to be a little disastrous if this thing starts zapping stuff. So I'll just kind of leave that as is. Maybe I'll even put the ground on it just in case. Sort of loop it in there that way, just in case I do something stupid. All right, and I decided to reattach this board to the brackets just so it's not flapping around and potentially shorting other stuff. So I'll just make sure that these are nice and snug, the two that look like they're for grounding purposes. This portion was the one that went to the switch. So I'll just connect that there, and I'll set this off to the side. Okay, make sure that switch is all the way to the left, and let's go ahead and apply power and hit the switch, and it wasn't working, so I kind of doubt it's going to work now, but we never know. Okay, yeah, that's not lighting up. All right, I've got the multimeter up, so right at this point, the inverter should technically be on. Let's see what we are getting voltage-wise at the input. I don't remember if it was these two. There's nothing there. Yeah, so it would be the two on the rightmost side. So it'd be this blue and the brown one. And it doesn't look like we're getting anything there. So that was with the switch on, right? Yep. So it just looks like it's not getting power for whatever reason. Oh, I forgot that I have to have that switch in the back to external power mode. Duh. All right, let's try this again. So it should be in fluorescent lamp mode. And let's see if we've got a voltage between this pin and the middle pin. So, okay, so we do have just under 10 volts there, as we can see. So it looks like it was supposed to be powered by 9 volts. Let's see what we have between. Whoa, it's smoking. Yeah, something is smoking on this board. See that? The wisps right there? Okay, let's disconnect power. Okay, that resistor is getting really hot. Okay, so that resistor connects between that point and that point. And the only other thing in series with it is a capacitor, and that's that capacitor. And I wouldn't think that a capacitor like that would cause it to start smoking unless the capacitor is shorted. I don't even know if this thing is oscillating at all. Looks like that's the, if this is a transistor, then that's going to be the collector. So it looks like the collector goes to the transformer, and that would kind of make sense. Let's see. So if that's the base, yeah, that goes to a resistor to this transformer. So it looks like that would be the one that turns the transistor on and off. That's another capacitor. So looks like that's part of the switching for that transistor. The other side goes directly to ground. So yeah, that's the one that's driving the transformer. Unless this transistor is shorted. I guess we can check both. We can check to see if this capacitor is shorted and if the transistor is shorted. Okay, so let's see. This is the capacitor. And doesn't look like it's completely shorted. Okay, the transistor between collector and emitter. That doesn't exactly show shorted either. Let's see. Let's do a diode check on that transistor. So I'm pretty sure it's probably going to be it is going to be an NPN transistor. So if we put the leads, the positive to the, what would be the base, and then one to the collector, that looks fine. And that looks fine. Wait, I just realized I connected the lamp to the to the wrong sets of connectors. It was supposed to go to that one. I put it on the one that goes to the incandescent bulb, so it wouldn't have done anything. So maybe it was oscillating after all. Let's hook it up right this time. All right, round 2 after fixing a bunch of mistakes that I've made, or correcting mistakes. I haven't really fixed anything. Okay, everything should be in the right mode. All I have to do now is turn on the switch in the front. And the lamp's still not working. Let's see, we should have about 9 volts between these 2 points. Yeah, 9.856. Okay, so is this getting hot? Yeah, that transistor is getting warm. Ow! Oh, that resistor's hot. So, yeah, there's definitely something wrong on this board. Well, I removed some components that I thought maybe could be problematic, but all of these capacitors seem to check out okay. The transistor checked out just fine. That resistor that was getting absurdly hot, even though it looks partially charred on the side, it's a 22 ohm resistor that measures almost exactly 22 ohms. This other resistor seems to be fine. Uh, Other than maybe the lamp being bad and that's causing this resistor to get like really hot, I can't think of much else other than maybe there's something wrong with the transformer itself. All the wires appear to be connected to all the terminals on the bottom, so I don't know. And I'm not about to take this apart. And unfortunately, I also don't have a replacement lamp that I could test out. So yeah, I'm not going to be able to make this lamp work unless I had a replacement to test with. So I guess we'll leave that one there. I can put the rest of this stuff on. That's just going to have to remain the way it is. Okay, I'm recording this like way after the fact, but I remembered that I had this assembly that has a CCFL and the inverter built into the back of it. And as you can see, it's lit up. So this inverter works. I could use it to test this lamp to see if the problem is with the lamp or with the inverter board. And so what I'm going to do is, first of all, disconnect power, unplug those, and then I can use these alligator clips to attach the lamp to the output of this little inverter. And what we'll notice is that once I apply power, the lamp still doesn't function. So it looks like it may be a problem with the lamp after all. We can also test the inverter by connecting the terminals from the CCFL on this assembly to the outputs, and we'll see what that does. Okay, so now I've got the inverter connected to this CCFL, and it looks like it's lit up, but it's just the reflection because it kind of focuses the light there. But if I apply power to the pins on the input, so this one is positive and the outer one is negative, you can see on this side it's glowing a little bit. You can kind of tell right there that it comes on. There you go, like that. So looks like the inverter does work. My guess as to what's happening and why this resistor gets so hot is maybe because this lamp is not providing a load. The oscillator portion of the inverter is like running way too fast to the point that this capacitor basically looks like a short to that resistor. And so that's why it starts heating up so much. But unfortunately, without a replacement lamp that would appropriately load this inverter, I'm not going to be able to do a good test of that theory. So that's my guess. And it looks like we've basically ruled that the lamp is the one that's bad. So that kind of provides a bit of an answer, I guess. So we're not left wondering what the heck is going on. And it looks like it's not a problem with the transformer after all. But let's replace the capacitor on the TV board and see if at least the TV will work. And it looks like I do have some 10 volt 2200 microfarad capacitors. So we're going from this Chang branded capacitor to a Rubicon. So let's go ahead and pop this in and hook up the wires from the deflection. And it does look like that capacitor definitely is in line with the deflection coil. So that could definitely be why that's not working. I don't think I saw any other capacitors that look bulgy or anything. I mean, there's still a possibility that some other ones are bad, but this one was obviously definitely visibly bad. So let's at least replace that one. And the new electrolytic is installed, and I've also resoldered the wires, the deflection coil wires to the board. I've put this back into the chest just to hold it in place so it's not flopping around. I've reconnected the anode cap and screwed in the ground. So all that's left to do is to apply some power and hook up the switch so that we can turn it on, and then we'll see if the TV works. All right, I've got the switch reconnected. I got to make sure that that's in the off position. Okay, I'm applying power. And let's go ahead and turn it on. Let's see, I got to set the switches in the front to TV mode. I almost forgot about that. Okay, so it's the third setting from there we go. So it's in TV now. Let's turn the volume down just so we don't blast our ears off with static noise. All right, here we go. Let's hit the switch. And I'm having trouble figuring out how the heck I'm going to hold this thing. Okay, I'll hold it by I'll grab its knob right there and I'll hold it that way. So, power. See if okay, we got static noise. You just got to wait and see if the CRT comes on. And yeah, it's working. It's got static, but the brightness is down, so we can't see it. Let's turn the brightness up. I think it was the center potentiometer. Yeah, there it is. So it just had a bad capacitor. And obviously, I'm probably not going to be able to tune into anything. Let's see. I'll try hooking up this alligator clip to the antenna connection. And see if it's better if I get the other camera. There we go. We can see it better that way. Let's see. I'm just going to see if it'll tune into anything. I kind of doubt it, but we'll see. Probably raise this up. There's a spot in this section where it's just kind of a black screen and it quiets down, almost like it tunes into something. But yeah, no, otherwise I can't tune into anything off the air. Well, at least it does tune. I took my 3DO that I still happen to have laying around in the garage. I hooked up an RCA connector and then this alligator clip to the center terminal. And if I just get this thing close enough to the antenna terminal, you can see that it will tune into it. And right now it's set to channel 3. So that's what it's tuned into. It still looks really snowy, so that wouldn't be an ideal method of injecting a signal into this thing. If you wanted to actually use it to watch anything, it'd be better to modify it and apply like a video signal directly into the whatever pin accepts the video from the tuner section. But as you can see, it does work, and there is audio. It just doesn't look great. The only other thing I was curious about on this thing was as to the oscillator for the siren sound. And if we just kind of barely push the power button, we can get it to make some interesting sounds. So I'll demonstrate it. I'm just basically going to make it make contact, but not completely engage it. So here we go. See what I mean? All that stuff's pretty much going to be capacitor based is my guess. However, this is going to get really annoying if it's constantly running. So I'm going to put this in a box or something. I don't know if removing the speaker from the circuit is going to affect it in any way, but I'm going to take the scope. We'll probe around in this section and see if we can get a waveform of what that tone looks like. Best as I can tell, even in siren mode, the speaker still goes through the amplifier. So this stuff is going to be generating a tone, and then that's going to be going straight into the amplifier. And I was looking at the data sheet, and it looks like pins 2 and 3 are the 2 input pins. One's the inverting, and the other one's the non-inverting. Not sure how they've got this all set up, but I can probe one of those two and see which one we're getting a tone at. And what I'll do, just so it's not so obnoxious, is I'll just put my thumb over the cone. That seems to muffle it enough that it's not too bad. Let's see what we get. There we go. It's on. So at pin 2, yep, we got something going on there. Pin 3, looks like that's going to be the feedback. Okay, so at pin 2, let's see, that goes around this way. All right, well, since we know that the speaker goes through the amplifier, I'm just going to disconnect one of the wires. It's it's really annoying. So that's what that tone kind of looks like. It looks like it's basically like a frequency modulated signal that's being generated. And let's turn up the voltage. It's really sharp down at the bottom, and then it kind of flattens up at the top. And you can kind of hear that in the tone. It does sound a little crunchy at the when it's at the top end. So let's see if we can figure out where that's generated. It's going to be down in this section, like I said, most likely. Oh, and as far as the frequency goes, according to the scope, it looks to be about 530 or so hertz. It's obviously fluctuating a bit, but it looks like at points it dips under 500. It's kind of hard to see in this capture, but it looks like in this section of the waveform, on the scope, it looks like it's a higher frequency, and as it gets to this sort of like peak, it starts the frequency starts kind of dropping a bit. It looks a little less dense. Like I said, we can't tell on the capture window, but that's what it looks like on the actual scope. I'll take a picture of it and then I'll just kind of post it to the side so you can kind of see what I mean. But it looks like that's what's generating that sort of like wee wee wee. It's the like this section's going to be the woo, but it sounds like it gets a little louder, and then it's like wee woo wee woo, like that. So I hope that's descriptive enough. I don't know how else to explain it. And with all that, I think that's going to do it for this one. I think the most fascinating part of it is the small, what is it? I think it's like a 5-inch CRT. Everything else is kind of meh. It's not all that exciting inside of this thing. I would think, if anything, I would maybe want to do something with the TV portion of this, maybe modify it a bit to some sort of display. I don't know. Comments, suggestions, thoughts, condolences, hate mail. Maybe just leave it down in the comments. But yeah, we'll just leave this here. Thank you all for watching once again, and I will see you guys around the bench.